Okay. Thought I'd go over an instrument I've had for quite a while in use, or had been using and then stopped using it, and now I'm needing it again. And would like it to work properly, work well. I've already done an electrical restore on the thing. Happy with it as is right now. Bunch of stuff needed some attention. I got this, oh gosh, I think 20 years ago. I got this from the original owner, my grandfather, rest in peace. He had this, he bought it, so I know its provenance. And he was kind of meticulous about taking care of his gear. I'm sure that when he had it, it was working just fine. In fact, when I got it, when he gave it to me, it worked. The only thing I did to it was replace the line cord because it was a bit crispy. And used it, on and off for years. It's not an instrument. I had it on my bench, but it was not an instrument I would leave turned on all the time. That's just never a good idea for this old tube stuff. You ain't using it, keep it off. And along about some time, I got a hold of some eye tubes. This is a 65 magic eye tube. Those of you familiar. The one that was in here was a little dim, so I got a few new ones and put one of those in here. I do remember doing that, and so used it for years. And then it sat for some time, and I decided to blow the dust off of it and fire it up, check it out, and it always had some little problems here and there, but it was nothing that I thought at the time, at least, needed much attention. I figured I'd get around to it. It was working more or less as worse. So, but I hadn't used it in a while, and fairly recently decided to pull this thing out and check it out, fix anything that's wrong with it, and there were some things, nothing major, fortunately, that were wrong with it. There are a lot of this vintage capacitor resistor testers. Now, I would never use this to test resistors. These days, you've got a bazillion ways to do that. Simpson 260 is probably as good as this. But for capacitors, this particular model, I've messed with a number of different models of capacitor checkers. This gives you a fairly comprehensive view of what's going on with them. I'll get into all that later once I fire it up and get to that part. Obviously, and cosmetically, it's in pretty good shape. I'm rather happy about that. Rugged as heck. And the cabinet it sits in is back here, and in the cabinet it sits back on an angle, which I always thought was a nice touch. On your bench, it looks at you up to your face, so you don't have to scrunch down and stoop down to see these indicators. This eye tube and this neon bulb here, which is important. So, what's in this thing? Better check the focus. That's there. It's got 4 tubes, 5 if you count this neon indicator. 1-B That's the power supply rectifier. All these, I don't know why they chose that. This thing was made, or well, introduced in 1948. I'm not sure what year this was made, but it was introduced in 1948. I noticed some of the, actually almost all of the tubes in here, but for this one I replaced, are date coded 1952. Or was it 53? Whatever. All the tubes are good. They work just fine. I've had to go through and replace a bunch of capacitors, and in fact I've got them stacked here. We'll get into that later. Well, the main control here is actually two pots ganged together. One of them is looks like a 2, maybe 5 watt. Good Lord. What surely is a wire wound potentiometer, a pot. And back here, maybe wire wound. Don't know, I've not measured. I don't have a schematic for this. I've never seen a schematic for it. I have a pretty good idea how it works. It's just a simple bridge with some accoutrements on it. But woe betide me, or anyone that has one of these, if this gang goes bad, you're never going to go out and buy a replacement for that. that would kind of suck. But as it is, these work just fine. I've not cleaned them. I tend not to do that unless there is a problem. Another one up here. It's another, you can tell because of its size. When you turn it, it kind of buzzes. That's wire wound, so that's got some wattage to it. It's interesting. Let's see, I hope this focuses. I'll hold it here. This bit here. You got this fairly high wattage. I think that's a 2 watt resistor. It's got a gold band, which means 5% tolerance. It's a 1.5K, green, brown, red. 1.5K resistor. But it's got this 100K 10%er, 10% tolerance, across it. Well, why would they do that? There's every indication that that's factory. That was not, somebody didn't just put that on there. In fact, when I got this, all of the wiring and all of the components are factory. The only thing that may have been replaced are some of the tubes. Well, I know one of them has. I did this one, the I tube. But now this is 1.5K at 5% tolerance. When I measure across this, it's exactly 5K. 5K 0, man. So this is trim. They took a resistor that was higher, a little bit higher, you know, and they lowered its resistance by tacking across whatever it took to make this resistor be a 5.00K resistor, and that it is, by every measurement. So I'm certain that's what that's about. This needs to be 5K, man. And then there's this pot. That's associated with the what they refer to as power factor. I'll get into that later. Yeah, see what else down in this part of it. This shows. These two big honking beeswax paper capacitors here. Kind of oddballs for this day and age. Let's see, what were these things? 1 microfarad, 200 volt each. Now they're part of the bridge, so those had to be close tolerance capacitors. That suggests, to me anyway, that for a 200 volt capacitor, yeah, it's 1 microfarad, kind of high for a beeswax capacitor, but some of this suggests that they were trying to get a close match between these two to match two legs of the bridge. As you may be able to tell, there's these yellow beasts up here. These two are shot. These beeswax things they're gone, of course. I had to replace every single capacitor in the thing, every single one of them. It was bad for various reasons. Actually, I'm going to use this instrument to demonstrate what its own previous innards were struggling with later. So anyway, that's what these two are. These are Mylar film capacitors. 10% tolerance. These two are matched very closely. I have a crap load of these. These are Western Electric capacitors. The voltage rating on the, well, not stated on the sleeves, it's 600 volts for those, which is remarkable for something that size. 600 volts DC. And I've tested it too, and they are. So, what's underneath? Flip him around here. Oh, by the by, the tube complement. V1-V, that's the rectifier. 6SL7, that's the amp for the bridge. 65, the I tube indicator. And then this beast. That was a bit of a mystery at first until I got to really looking around and how this thing's set up. It's a 6Y6, it's a beam power tube, an amplifier, often used as audio amplifiers. But where they're using it in here is as a voltage regulator, which has to do with a certain test that this thing can do. And rather than just do some stupid thing like have a rotary switch selecting taps on a resistor divider, this thing actually has a variable DC supply in it, controlled from the front panel for a certain test that this thing can do. It's a leakage test. And I'll demonstrate that. Very, very well done. Other than military instruments of the civilian sort, or the kits and these ICOs and the Heath kits and everything, this is the best one I've ever seen. And shows it. This transformer, oh boy. If that goes out, my condolences. You're not going to go to Radio Shack at that. It has a single primary, of course, for the line in. A bunch of secondaries. One of them high voltage, 600 volts or so. It's got 11 leads coming out of it, and those include the primary winding line in. So he's good. It doesn't look like it's suffered any grief. I'm certainly not going to mess around with that. What works. So what's underneath? As you might be able to tell, there are a number of components in here that are certainly not of the age of this instrument. As I said, I'd replace a line cord. I've since replaced it again with one with the proper ground on it. So, because this chassis was not earthed, and we can't have that. And while doing this, I meant to put a line fuse in it. I forgot, and so it's a simple matter. I'll just pull off the switch and put a wired little 83 fuse in there, probably an amp and a half or something, just in case something happens. It doesn't smoke, blow the fuse. And now the chassis is earthed, ground, safety grounded, no trouble. These orange drops here and this blue drop were all these wax guys, every one of which is actually quite bad. It's amazing the thing worked at all. These two here are replacing what was a two-section electrolytic a pyramid. I always like that logo. Pyramid cartridge dry. Cartridge with a J. And this was 4 and 4 microfarad, 250 working volts. DC, of course. Right, this is so shot, it's ridiculous. So that's what these two yellow jacket caps here. Now these are Japanese made. These are actually, these were Y caps. They're rated in volts AC. Made, you know, Shizuki. Anyway, this was 2 4 microfarad capacitors, 250 working volts. These are each 10 microfarad at 250 working volts AC, which probably puts these up in the realm of 600 volts DC. And this, there's no way they're ever going to see that. There's only about 250 volts across this, both of these. More on one than the less, just because the way they're strung in. These are nothing but power supply, DC power supply for the bridge amplifier, power supply filter capacitors. And the 1-V tube is able to handle, with the voltages being used on it, 40 microfarads here with no trouble. So going from 4 and 4 to 10 and 10 is not an issue at all. Indeed, it should actually improve matters, so make it a little bit more less ripple. Not that that would be a big deal in an instrument like this, but because these have so much lower, because of the kind of capacitors, they are much lower electrostatic resistance, ESR if you like, than any beast like this would. At RF, they do a better job at filtering out line crap noise and spiky stuff. So that's what the capacitors, as I said, I've saved them all. I don't throw these away. Sometimes I'll re-stuff them, melt all the wax out, pull the guts out of the bad guts, stuff a modern capacitor in there, which, you know, they fit in usually quite well, and reseal it up with the original wax and make it look like it's the original deal. Occasionally, for something like this is not a desk or table radio or, you know, nothing like that. This is a test instrument. It just needs to work reliably. I'm not going to restuff and hide the fact that I replaced some capacitors in it. That needs to be here, just what has been done with it. Did have to replace a couple of resistors. I think, what was it, 2 of them? One here, and what was the other? This one. They all checked within tolerance, except for 2 of them. One was this one up here, 100K, part of the power supply. That does not surprise me. And this one down here is a 1 meg. And they had a 20%er in there, and where it is in the circuit, it kind of matters. So it was off more than 20%. So off it went, and I put a 10%er in there, which is actually measuring it. It's very close to 1 meg. So this big honking 100 ohm, spot on. Don't need to mess with that. Let's see, what else was it down here? All the pots, fortunately, check good. And I haven't had to clean them. Well, to do so would be difficult anyway, because of the way these things are assembled. There are really no holes or openings to put some cleaner in it. I've seen guys drill holes right through that. No, don't ever do that. End up drilling right through the element in there, and you're done. Oh, it has 6 decades of ranges here on both resistance and capacitance. 6 decades, which corresponds to 6 decades on this wafer switch. That's the range switch. 6 decades of capacitors, starting with a 100 ohm and ending up with a 10 meg ohm. And I checked each one of those, and man, they're spot on. They're 1%, within 1% of their rated value, and it's hard to see. Maybe you probably can't, but it's even marked on there under these coverings, which I'm sure were meant to keep mold and moisture out. Seems to have done the job. But so none of those precision resistors need to be replaced. The two capacitors that need to be close tolerance, I'm not going to call them precision, are matched and measured to be spot on 1 microfarad. So electrically, other than me putting a fuse in here, which I'll do when I'm finished with all this, before I box it up, it's done. I'm meaning I'm finished working on it, and it's working just fine. So I'm going to do some other stuff. You gotta get this guy, he's not plugged in right now and all that, just because of handling and so forth. And I'm going to change the lighting too, because I got 600 watts of stage light on here right now, and it'd be kind of difficult to see the indicators on here as I go through some of the motions with it. So I'll do that. This will be I'll be right back.